Hi there! Jetpack Compose is a modern declarative toolkit for building rich native Android UIs. In this video, we'll show how to add Compose to an existing application. Compose can coexist with the View system, enabling you to migrate gradually. We'll go through the different APIs available to do this and how to best integrate these two systems. A common approach when refactoring your app to a new technology is adopting it in new features. For example, new screen you are building. In this case, Compose code will interact with the View system at the edges. You can also perform a gradual migration by having some parts in Compose and others in the View system. For example, migrating a recycle view to use a lazy column, but keeping the outer layout as a constraint layout. Or vice versa, use Compose to host your custom views or some views that might be not yet available in Compose at the moment, like map view. Alternatively, migrate whole fragments or screens to Compose one at a time. This will also use the View system at the edges until the whole application uses Compose. Use the strategy which works best for your project. Next, we are going to see the different APIs you will use to enable using Compose in an existing app. Compose needs a host activity or view in order to render UI. If you want to have Compose at the root level in an activity, you don't need XML code. You can simply call the setContent method, which is an extension function on component activity. And that's it, you're in Compose land. If you want to use Compose in fragments or in existing view layouts, use Compose View, which is an Android view that can host Compose UI content. Imagine we want to migrate parts of an existing app to Compose. This screen is a fragment with a coordinator layout, app bar layout, and constraint layout. Instead of displaying content using views, we want to use Compose instead. We can replace the constraint layout and all content within it with a Compose view that will host Compose code. In our fragment code, we inflate the layout XML resource, find the Compose view, call setContent in it, and you're in Compose land again. If you want to have Compose at the root level in a fragment, you can use the Compose view without needing an XML file. Create the Compose view inline and use setContent as before. If you use multiple Compose views, like this example which uses a linear layout with two Compose views and a text view, just remember to give them a unique ID to enable SavedInstanceState to work. You can also host views within Compose. This lets you display any custom views you might have or views not yet offered in Compose, such as map or web views. To do this, use the Android view composable. You can pass in a view and you get a callback when it's being displayed on the screen. Android view will render the view from the factory function viewBlock parameter, view that you will get in the update callback after it's been inflated. There, you can configure the view as you wish. Let's use this in Crane, one of our sample apps. This is a travel app that is part of the material studies. When you tap on a destination, it shows where the city is on the map. Crane is built in Compose. However, the Google Maps SDK for Android doesn't provide a Compose version of the map view yet. Thus, we need to use Android view. In map view container, we create and remember a map view. Then, we call Android view with the lambda providing it. In the callback, we can have code as if we were in an activity or view. Here, we call getMapAsync on the view as the Maps SDK documentation says. Then, we add a marker and move the camera. That's it. What's even better is that you can also interact with the view and communicate between views and Compose seamlessly. Here in Crane, we have the zoom control buttons written in Compose and the map view. You can see how you can interact with the map view and update it whenever you tap on the zoom buttons. Isn't it neat? This is because the Android view lambda recomposes whenever a state value that has been read in it changes. So if we had a zoom state in Compose that we modify with the zoom controls composable, whenever we read zoom in the Android view lambda, Android view will recompose and the new zoom will be set on the map view. If you have XML code you want to embed in Compose, you can use the Android view binding API. Obviously, this requires view binding to be enabled. Simply call Android view binding with the inflation of the binding of your layout as a parameter, and you can access your bindings in the update lambda. If you have mixed view and compose code, you might want to access resources from the view system. For that, we have helper methods you can use. To access strings from the view system, you can use the string resource method, passing in a string resource ID. Similarly, dimension resource is available in case you need to access dimensions. But there are much more than this. For example, here we get a vector asset and apply a tint using resources. You can see the trend, right? For different use cases, when interfacing between Compose and views, you can use some classes from the view system in Compose, using ambients. For example, if you need the context, you can use the context ambient. What happens with your current app architecture in Compose? You don't have to change anything if you don't want to. We are providing helpers for libraries that integrate perfectly with Compose. With the ViewModel function, you can call architecture components ViewModels from your composables. It returns an existing ViewModel or creates a new one in the given scope. It will be retained as long as the scope is alive. For example, if the composable is used in an activity, ViewModel will return the same instance in all composables until the user moves away from the activity or the process is killed. Following the crane sample, here we have a ViewModel for the app. It contains the logic of the main screen and exposes some information using LiveData. Here in our composable, we can grab an instance of the main ViewModel calling the ViewModel function. ViewModel can also take a factory in case you need to pass some dependencies to it. And that's it, you don't have to do anything else. You can start using your ViewModel in the composable. Compose also comes with extensions for working with LiveData, Flow, and RxJava. Each of them are available in their own different artifacts. This will register as an observable and represent the values as a state. Every emitted value will cause a recomposition in those places where state.value is used. In the following example, we'll be using the LiveData extension that is available in the runtime-LiveData artifact. The ViewModel exposes the suggested destinations LiveData, which we use to call observe as state to listen for new destinations. Then, we can pass the destination state to another composable that will recompose when reading it. On a different note, it's important to support saving your UI state in a way so that when the activity or the whole process is recreated, the screen is restored properly. In the view system, this goes as follows. You might store some value in a private field, create a string key which will be used to store the value, and then save the field in the bundle of the activity callback on SavedInstanceState. Then, you would retrieve that data from the bundle in onCreate. How can you do the same with Compose? In Compose, with SavedInstanceState, in addition to retain state across recompositions, it will also restore when the activity or process recreates. And you don't even need to specify any keys. A compile time generated key will be used. All data types that can be added to a bundle are saved automatically, but if you want to save a more complex data structure, there are several options. Imagine we have this city data class with name and country we want to save. The simplest solution is to just use the parcelize annotation. In this way, the object becomes parcelable and can be bundled. However, if for some reason the parcelable solution doesn't suit you, you can write your own rule using a saver, where you convert an object into a set of values that the system knows how to put in a bundle. Here, we use a list saver for this. In the save lambda, we let Compose know how to convert a user object to a list of string values. And in the restore one, we describe how to convert this list back to a city object. Now, in the SavedInstanceState method, we pass in this saver. At this point, we've written a lot of code that is Compose only, but also Compose code that interacts with the view system. When making changes to your UI, testing is indispensable to verify that you haven't broken your app. To test Compose-only code, you can use the Create Compose rule in your instrumentation tests. Your test must contain it. This rule handles all the synchronization for us and sets up the content so you don't have to care about activities or views. In your test method, call the composable under test inside the rules set content and assert using Compose testing APIs. For tests that render view and compose code, instead of using activity scenario rule, as you currently do with Espresso, you need to use create Android compose rule. The compose testing framework plugs itself into Espresso, and you can use both frameworks at the same time to test your app. In fact, Espresso will wait for compose to become idle. To test Crane's details activity that contains the map of the city, we need the create Android compose rule, since we'll be interacting with compose and view code. In the test, we can use compose testing APIs to check for composed UI, and Espresso to check for views in the view system. Also, you can use the onActivity method of the scenario of the activity rule to access information from the map view, which was inside Compose. Here, we grab the camera position from the map view and assert that it is the correct one. Cool. Next, Chris will tell you more about using Compose in existing apps. Over to you, Chris.
Thanks, Manu. And hi, everyone. I'm Chris. And I'm going to start with a topic which is important to all apps, and that's your themes and styling. We recommend using material design to theme your apps. It's built on 3 key pillars of typography, shape, and color, which are a great way to systematize your theme and give it some structure. To implement this, currently, you would use the material components for Android library, which I'll refer to as MDC from now on. Now, similar to MDC, Compose offers an implementation of material design, and that includes the theming system. If you take a look at this example, you'll see that we're creating a color palette setting the primary and unprimary colors. Then, to use that in Compose, you would use the material theme composable, passing in those colors. All of your material components will then use those colors as their color palette. Now, this is great if you're starting from fresh with a brand new app. But if you're adding Compose to an existing app, you will likely be starting from something that looks like this, with a large number of themes, with colors, text appearances, shape appearances, and all the other things needed to style the app as needed. When you introduce Compose, you'll then need to redefine your theme in Compose for those screens which you migrate or later create. Now, this results in 2 copies of the same theme in different systems, which makes it harder to maintain or later update. Now, this might be okay. If your plans to fully migrate over to Jetpack Compose in the near future, you will need to eventually create that Compose version of the theme anyway. For longer migrations, ideally we would remove those 2 sources of truth and make one depend on the other. As Compose is the future, ideally we define our theme in Compose and then have it automatically reflected in the view system. But unfortunately, that's not possible due to limitations in the view styling system, where we can't modify themes at runtime. Instead, we've published a new library this week called MDC Compose Theme Adapter, which allows you to reuse your color, text appearances, and shape appearances from your MDC theme within your Compose theme. You can grab it at this URL. If we go back to our example and then introduce the theme adapter, our Compose theme becomes a simple call to MDC theme. The adapter library also allows you to customize the created theme parameters. So say we want to tweak the colors just for our Compose elements, we can do that. Instead of calling MDC theme, we would call the create MDC theme function, modify the parameters needed, and then pass them through to material theme ourselves. But be aware there are a few limitations to the theme adapter. Firstly, it only works with MDC themes and not, say, AppCompat or platform themes. As we mentioned earlier, Compose implements material theming, and therefore we need the equivalent theme information to map between the 2 systems. The second limitation is that it only currently reads the color, text, and shape appearances from your theme. The key missing thing here is that it does not read any default widget styles. And this is because Compose has no concept of default styles declared in your theme, unlike the view system. As we mentioned earlier, any modifications you make to the theme within Compose will only work in Compose. It's a one-way street due to that limitation in the view system. And finally, the adapter doesn't handle any window level attributes. And that neatly leads us on to working with the system UI in Compose. Now, this wouldn't be an Android development video from me if I didn't talk about going edge to edge. If you're not quite sure what I mean by that, you can check out some of our existing content on going edge to edge. As a quick recap, going edge to edge means drawing behind the system UI, primarily the status bar and navigation bar, like in this example. Now, this involves 3 steps. Step 2 is no different in Compose, so we'll focus on just steps 1 and 3. So step 1, changing the system bar colors. As we mentioned earlier, MDC's theme adapter doesn't provide any special handling for window attributes. So we need to think about how attributes like status bar color can be used in Compose. We've published a gist containing an experimental utility called SystemUiController, which allows you to change the system bar colors from our composables. Here you can see the set system bars color function, where we're setting the system bars to our surface color. One of the cool things it does is that it automatically changes the color of the system bar content, such as the icons and text color, to maintain contrast against the background color we provide. You can check it out at this URL. One thing you might be thinking though is that you can now remove the relevant attributes from your view theme. Unfortunately, you still need to set these in your theme, as they're used for the initial decoration of your activity, which happens before any of your composables are actually run. Next, we come to step 3, avoiding overlaps with the system UI, which is primarily around using WindowInsets. Compose doesn't currently have any built-in way to handle WindowInsets, but the power and the flexibility of the modifier and layout system mean that we can build it ourselves. Again, we've published an experimental solution as a gist at this URL. That gist contains a number of modifiers which greatly simplify the handling of insets versus, say, the view system. Let's take a look at 2 examples of these modifiers in action. The first is the example of a floating action button, which we want to place in the bottom corner of the screen with 16 inches of padding, marked in green, and then implemented as the first modifier. We also want to move it out from under the navigation bar, so we add the navigation bar padding modifier too. Now, compound padding like this is very difficult to implement in the view system, and I think this demonstrates how the modifier system simplifies key use cases. Next up, we have an example with a hero image at the top of the screen. As we go edge to edge, we want that image to draw behind the status bar like so. However, you can see that the status bar content is now difficult to see. We need to give that content some visual background protection to maintain contrast. One way we could do that is by adding a spacer element which matches the size of the status bar, but draws the translucent color behind it. Here, we're using the status bar height modifier to automatically match the height of the status bar. As an alternative, we could use SystemUiController, which we mentioned earlier. Next up, we're going to talk about fonts. Now, I'm sure many of you are using downloadable fonts in your apps. Unfortunately, downloadable fonts are not yet supported in Compose. For now, the alternative is to download and bundle those font files directly in your APKs by placing them in the font resource folder. Once you've done that, you can use them in Compose like so. Depending on the weights and styles you bundled in the APK, you can create a font family from the individual fonts and then use them in your text styles. But be careful if you're using the MDC Compose theme adapter. The adapter does support text appearances which use font files from your resources, but for a partially migrated app, it's also easy to accidentally use a downloadable font, which will work in your view-based UIs, but then doesn't work in your Compose UIs, so just be careful. Our final section of this video is all about image loading and async operations. For image loading, one way to achieve this is to use the Compose extension for the coil image loading library, which we've published here. It's very easy to use. In your Compose code, you would call coil image, passing in the URL, the content scale, or any other parameters to configure the image. The library also provides a variant which fades the images in when they're first loaded, and that's called coil image with crossfade. Now that's great, but there are other use cases where you might need to run asynchronous operations within your Compose UI. Let's look at a general pattern for async operations that you can adapt for your use cases. Let's imagine that instead of using the coil extension library, we want to use another image loading library, like say Picasso. We'll start by creating a composable that takes the image URL as a parameter and then returns the result we want. In this case, an image asset, which is Compose's equivalent of a bitmap. In there, we need a place to hold the result, which we do by creating a remembered mutable state. And this is also our return value. So that's the start and the end of our composable function. Now we need to implement the actual image fetching. We do that by using the onCommit method, which is available to every composable function to be able to execute side effects during composition. We pass in the URL as the parameter to onCommit, which means that the side effect will only be run when the URL changes. In our onCommit lambda, we can then load the image with Picasso. If the image load is successful, we convert the bitmap to an image asset, and then we can update our image state. Next, we can call Picasso with the URL and then also the callback target we created. Now, as it's possible that the composable could leave the composition before Picasso finishes loading, we use the onDispose callback inside onCommit to clean up any resources and cancel any pending requests. So that's our composable function to fetch the image, but now we need a way to display it. In this example, we've added a Picasso image element, which takes the URL as a parameter. It then calls our fetch image composable and displays the result in an image, or displays a simple placeholder box while the image is loading. If you'd like to see some more examples of async operations in Compose, you can check out the OWL and Jet Survey sample apps, which have added support for the back button and runtime permissions. If you'd like to try out migrating an app to Compose, we have the Migrating to Compose code lab for you to try, as well as the TV and Sunflower sample apps, which are being migrated to Compose as we speak. So check out those if you'd like to see some more complex examples or even help out. For the Compose Alpha launch, we've published a number of new samples, code labs, and docs this week. Now, Compose 1.0 will be released next year, so now is the best time to try it and give us feedback. The main concepts are established, but APIs are definitely still evolving. Your feedback and feature requests can help shape it. You can do that on the issue tracker or talk to us on Slack. Thanks for watching.